Here we are at the bandsaw. The first step in making the screwdriver is to saw the ends off so that we have a nice flat end to be able to drill a hole in. Also there's probably some sand inclusions on the end of your bar so that if you use the drill bit on there it might dull the drill bit. Okay, so a center drill. We're going to have to actually center drill one of the ends of this bar. So what we can do is just saw the ends off, maybe 1/4 inch of it of each end of the bar off. We're going to need at least 8 inches in order to make our screwdriver, so we have plenty here. Okay. Just a quick review on the bandsaw. Remember that you need a key in order to start the bandsaw. Start button's right here. And because we're cutting something round, we want to use the bandsaw vise, okay, in order so that the part doesn't spin. So what we're going to do is put the vise on its side, not up like this, okay, because this won't be stable. We want to put the vise on its side and grab our part. And we're going to be pushing our part through with a piece of wood in order not, when we go to the back side, so that we don't cut into our hands. Okay, the next thing we want to make sure is that the guides are down only about 1/2 inch above our workpiece. Okay, so we want to move the guide down. The way you do that is in the back of the machine here. There's a screw. Okay, undo the screw. That'll allow the guide to lower down and then reclamp it. Okay, so we're ready to saw this off. The other thing you want to remember is that you can lubricate the saw blade with some wax. So what you're going to do is turn the saw on. Push the wax up against the saw blade for a couple seconds until the blade goes around one time. Okay, at this point, we're going to take 1/4 inch off the end. Make sure you got your piece of wood behind here. Try to make it as square as possible. Okay. You want to ease the pressure on the saw blade as you're exiting the cut so that it doesn't quick, go through the back side and scare you and have you go into the saw blade. Okay, the other thing is, remember when you're pushing on the machine, pushing on your part, make sure you have one leg forward. Go ahead and pan down there. Make sure you have one leg forward so that, okay, come on back up. So that as you're pushing, if something happens, you have a foot to push back from. You don't want to have both legs back like this, so that if something happens, you have no way of pulling yourself back away. Okay, so that's one thing I want you to be careful of. Okay, at this point, we're just going to flip around the other side and then saw it off. And okay, don't pull your extra piece of stock out. You know, you have your end you cut off. Wait till the bandsaw blade turns off before you go and you remove that. That goes in the scrap pile, the aluminum scrap pile to be remelted. Okay, turn on the machine again. At this point, we're ready to go to the lathe and machine our screwdriver onto that. At this point, I'd like to discuss the operation of a metalworking lathe. This is a 13-inch swing. In other words, the lathe can turn a part that's 13 inches in diameter over the way. This is the way right here, this part of the lathe. This is with the actual accurate surface that the carriage, this part right here, rides on the ways. Okay, and one thing I want to point out though is it cannot machine something that's 13 inches in diameter if the part is long. If the part's long, you're going to have to clear the carriage here, so it's probably only going to machine something maybe 10 inches or 9 inches in diameter if it's a long part. 13 inches was just a face part. Okay. I'm just going to go over some of the parts of the lathe and the safety on this lathe, and then at that point we'll start machining the screwdriver. At this point you should have a sharpened tool blank. The blank is 1/4 inch square. We talked about how to grind that, and it should have both ends already have been sharpened. Okay, the roughing tool, and then the tool for actually creating our chamfers and being so that you can machine in both directions. Okay, it's more of a utility tool. Okay, so we have a 3-jaw chuck, which means that all 3 of these jaws will move synchronized to each other, so that it will always center a part that's put in the 3-jaw chuck. It's kind of similar to a chuck that you have on a drill press. Okay, the movable part right here, as I said before, this is called the carriage. Sometimes it's called the saddle. This lever here turns the cross feed, which changes the diameter of the tool. This dial right here moves the long feed. So this is actually the turning direction. We're actually going to be machining towards the chuck. Okay, it's more efficient to machine towards the chuck because the bearings and spindle are set up to take loads towards the chuck. Okay, so in and towards the chuck, our tool will be pushing on our part. Some other parts of the lathe are the tailstock. This unit right here is called the tailstock, and this will help support our screwdriver when it's sticking out of the chuck more than 3 times the diameter. So that's the rule of thumb. If your part is sticking out of the chuck more than 3 times the diameter, the length sticking out is more than 3 times the diameter, then we're going to have to support it with a tailstock. That's the normal rule of thumb. Okay, and we'll show you how to operate that. You see some of the safety features on this lathe. The lathe at any time in any emergency can be stopped by pushing on the foot pedal. Okay, this foot pedal does 2 things. It turns off the spindle. In other words, the motor shuts down, and it operates a brake in order to stop the spindle as fast as possible. Okay, so the chuck is connected to the spindle, and that's the part that actually turns. This whole area here is called the headstock, and as I said before, this long surface here is called the way or bedway. Some other parts of the lathe. This right here, this rod, is called the feed rod. Okay, and this screw right here is called the lead screw, and they're used for 2 different things. The lead screw is used for threading operations. The feed rod is used for machining operations, where we just want to remove a certain amount of material. So it's very important that you're moving the right. If you're moving the feed rod and trying to do threads, it's not going to work, and we'll show you how to set that up here. Okay. In order to turn the power onto the machine, you turn on the switch below here. Okay. At any time that you're working with a chuck or measuring something or touching the chuck, I want this main power shut off. Okay. There's also an emergency stop on these machines, which you can press right here. In order to release them, you turn the collar in the direction that it indicates. Some of these emergency switches are a little loose, so I prefer that you actually, if not both, just shut off the power at the main source. Okay, so that when you're operating the lathe or you're measuring something, it's not going to turn on accidentally. So, in order to set this up, in order to go to the proper speed, if you look at your handout, it says that we should be, you see, at 1320 RPM. Okay, so there'll be a picture in your lab that I'm going to hand out with you, but I'm going to show you how to set up the lathe for 1320 RPM. It's very important that you do this correctly, because if you do it incorrectly, you can grind the gears or cause permanent damage to the machine. Very expensive. You see, it says right here, stop the lathe to change speeds. So anything that you change in this upper area here, you have to stop the lathe. Down here it says recommended to shift the feed box levers while the spindle is running. So if we're changing any of these gears up here, we do it while the spindle is off. If you do these down here, we can actually do it while it's running or while it's off. They may or may not go into gear while it's off. They may not mesh into each other very easily. Okay, this is a gear-driven lathe. Okay, so there's no play. In the other machines that we had previously, they had a belt. And the belt would slip if you got into an emergency situation. On these lathes, there's no second chance. Okay, if your hand's in the way, it's going to take it off because it's gear-driven and it's going to use all of its power to do whatever it can. So you got to be really careful. Okay, so what are you going to do in an emergency? Just stomp on that brake. Okay. Okay, now we want to set it up at 1320 RPM. Okay, so if you look here, there's blue numbers and red numbers, and there's an H and L. It's high gear and low gear. Okay, so this lever on top switches it from low to high gear. We want it to be in high gear in order to machine at 1320 because of the fact that it's the red numbering. It's the high gear range. Okay, so the second thing we're going to have to do after we put that into high gear is to change the selector switch so that it's down at the 1320 level. Now you can see right now it doesn't want to go into gear. Okay, and the reason for that is because the gears aren't quite meshing. We may have to turn the spindle a little bit in order to get it into gear. You have to wiggle the spindle back and forth a little bit. Okay. Okay, the next thing that you want to do, once we have the speed right, is we have to get the feed rate correct. Okay? The feed rate is the speed at which this carriage will move when it's machining, if you're using the automatic feed method. Okay? Now, when you first start out, I want you to do it by hand so you can feel how much tension you're putting on the tool, how much force you're putting on the tool. After you get good at that, then you can use the automatic feed and you'll get a much nicer surface finish. Okay? So, a couple things that we need to look at. As we move from the top down, okay, we notice the next thing we see here is the feed direction. And if you look closely, it shows an arrow. Right now we're set up so the feed direction is towards the chuck. That's the way we want to be. Okay? If I would put this in the opposite direction, okay, the feed would be in that direction, and that's not the way we want to machine. So this switch right here needs to be feeding towards the chuck. Okay, the next thing, if you look at your chart, or step number 5, you'll see that we need to be in BE1 as the gear ratio for 4/1000ths of an inch per revolution. Actually, it's 4.2 thousandths of an inch per revolution. Okay? So in order to do that, BE1, we have to look down here and now change these. It would be a good idea to change these with the machine on. Okay, so we'll have to go over and show you how to turn on the machine now in order to set the feed rate. Okay, the next step, what we're going to do is we're going to turn the spindle on and make sure that our feed rate is correct, and we have to actually have the spindle on to make sure these are in gear. Okay. You can turn it back and forth a little bit. See if you can try to find one of the gears. You don't want it to be between two gears. Otherwise, it'll grind. When we first turn the machine on, it'll start to grind a little bit. Okay. In order to turn the machine on, the spindle on, we pull out on this red handle here. You see the red handle? Down below the feed rod, there's a red handle. And we push upwards. Okay. Make sure everything is clear of the spindle. Okay. Now, of course, we have to have the power on in order to do this. Power's on. Okay, our emergency stop is out, and our spindle is clear, so we can turn it on now. Okay, now I want you to notice one thing, that the feed rod is not turning, and the lead screw is turning. Okay, so that's something we have to change. We want to make sure that the feed rod's turning and not the lead screw. We're not going to be doing threads, so I'm going to walk over here. Keep your foot near the foot pedal. and I'm going to turn it into feed rod mode. You now notice that the feed rod is turning, and the lead screw is not. Okay. Now we need to go into gear BE1. Okay. So up here we need to be in B, which it already is. Okay. Remember, if we wanted to change this upper gear, we'd have to turn the lathe back off to change that upper gear. Okay? Then E down here. Okay, when you switch the gears, make sure you do it fairly quickly, because if you stay in between the gears, it's going to grind them. And then we want to be in the 1 position. Okay? So we're in BE1. We've got the feed screw going. Everything's set for our lab. I'll demonstrate how the foot pedal works. Right now, if we want to put the emergency brake on, okay, it not only turns off the spindle, it brakes it. Okay. Now, in order to start machining again, this might confuse you, but you have to turn the handle to the off position before you can turn it on again. Okay. So normally you would turn that off like that. If you want to slow it down a little faster, you can push the brake on. Okay. Okay, now if we're going to start goofing around with the chuck, we want to make sure the power's off. Okay, and at this point we're pretty much ready to start setting up the machining operations. Okay, so we're going to put our part in there. We're going to use a chuck key. Looks like this. Okay, the chuck key will go. Remember, I got my power off at this point, so now I can touch the spindle. Okay, chuck key goes into the square hole on the chuck. Do not adjust the square hole on the spindle. If you loosen these up, the chuck will come flying off and injure you or someone else. Okay, most likely you. So what you want to do is put the square part of the chuck key and open the jaws wide enough to fit your part in there. Okay, here is our screwdriver blank. Now, in your handout, it says you want to place it in the 3-jaw chuck with about 3 to 4 inches sticking out in front of the chuck. It's a little more than 1 inch in diameter. Okay, so if you're about 3 inches sticking out, you should be okay to machine about 2 inches down on this without supporting it with the tailstock. We can just machine it on the outside without supporting it on the end. Okay, so what I'm going to do, get my carriage out of the way. Okay, at this point, what I want to make sure I do is, you probably don't want to put one of your parting line, the actual parting line of the casting, you don't want to put that on one of the jaws, because that might upset the straightness of your part. Remember that if it can't be in there very crooked, otherwise you're not going to have enough material when you go to machine your screwdriver. You have to have an inch diameter at the end. If you don't have enough material, you won't have an inch diameter screwdriver, and you'll have less points then. Okay, the next thing you don't want to do is ever leave the chuck key in the chuck. Okay, this is the most dangerous thing that I'm showing you. If that was left there and somehow you turn the machine on, this will become a part of your body. It will either go through your chest, in your eye, somewhere, maybe kill your neighbor across the way here. Okay, so I will yell at you if I see you leaving your chuck key in. If it comes out of your hand and is left in here, I will yell at you. Okay, it's not safe. It's about the most dangerous thing you could do in this lab. Okay, now we have about 3 inches or 3.5 inches sticking out. It's tightened, okay, in the chuck, so it's not going to come out on us, hopefully. Make it fairly tight. I mean, not gorilla tight if you're a big football player, but nice and snug. Okay? Okay, at this point we actually have to set up our tool into the tool holder. Okay, so we want to get one of these little specially machined tool holders. Okay, you can see that it has a little groove in there. And we're going to put our roughing tool. Okay, you can see a roughing tool here. That sets right inside there. You can see that. And then we're going to put that in our tool holder. Okay, there's 3
screws here, but we're only going to need to use 2 of them. Okay, you only need to use 2 of them because only 2 of them will be able to tighten up on your part at one time, your tool holder. Okay, so you want, if you can see, zoom in on that, you can see that we have 2 screws holding down on the piece of high-speed steel that we machined. Okay, at this point, we're going to need to tighten those. Grab a. Where are they here? Okay. And you might ask, you know, this is in the point facing the wrong direction. Why do I have it like this? I can actually turn this to 4 different positions, so I can flip this around. I could actually have 4 tools on here machining. You know, I could machine on one tool, then rotate it, machine on another one, have it sticking out over here. It's kind of a neat machine. And they all lock in place. Okay? Now, so what I'm going to do is I'm going to set this up so it's sticking straight in that direction, and it locks in place, and then I'm going to turn the little lever on the top and lock it down, snug that down. So now this is not going to be able to move. Okay? Okay, now what I'm going to do is I'm going to come in and start to cut on our bar. Okay, at this point we have our tool in the right position, ready to make a cut. Okay, remember that the cross feed changes the diameter of the part, and the long feed is what we're actually going to be doing our machining. So what we're going to do is we're going to come in and make a cut that just starts to take material off of this, and then we're going to move towards the chuck. Okay, here's where the dangerous part comes in. What's going to happen is there's a possibility of this chuck down here hitting other parts. So the problem is that we have to not only look at what's going on with the tip of our tool, we also have to look at what's going on with the rest of the rotating equipment and the stationary equipment, or the carriage here, so that we don't start machining parts of the lathe. Okay, this particular lathe, I don't know if you can see this, has a chunk out of the front edge of this the tool rest here. This is called a compound rest. This area right here. So right on the front of here, you can see there's a big chip. Okay, that was caused by the bottom of this the chuck jaw hitting the lathe when an operator wasn't paying attention. If you do something like that, you're going to have to sign the wall of shame. On the back wall of this lathe, there's a little place where you can sign your name that says that I injured the lathe. Okay, so try not to show up on the wall of shame there. Okay, think about what you're going to do. What I would do before you make a cut is without the chuck rotating, see if you can move your part in. Okay, see how far you can go before something is going to hit. Okay, so I can go pretty far, and I also have to have the actual tool near where it's going to be machining, and I can go about a half of an inch away from the jaw of the chuck before anything's going to hit. So I got to keep that in mind when I'm machining, and that way I won't get in trouble. Okay. So we need to. Okay, we have our chuck tightened. We have our tool tightened. We have the rotator device here, our indexing tool. We have that tightened. We have the compound rest. This is tightened. This thing can rotate, and that's tightened. We have our cross feed. Okay, we want to get that near where we want to be. And then our long feed, we're going to feed this by hand. Okay, so what we're going to do is bring the tool so it looks like it's almost touching the surface. Okay, we're going to turn on the lathe, and then we're going to come in and touch the surface and make a pass by hand. One of the things you can do in order to lubricate your workpiece is you can put a little bit of wax on the surface of your part in order to lubricate the tool. Your tool will probably only last for a few passes the first time you use it because there's a lot of sand in the surface. So you're going to have to intermittently sharpen the tool when it starts not to cut so good anymore. Okay? At this point I'm going to put some wax on there, and then we can start to cut. Okay, you can take some of the wax, kind of rub it on the surface. Okay, let's get some on the surface there. That'll tend to lubricate the tool as it goes around. Okay. the reason why we use wax is it doesn't make as much of a mess as oil or some other liquid type material. It's going to throw it all over you and your neighbor across the way here. Okay, at this point I'm going to turn on the power. Make sure our on switch is in the neutral position. Turn on the power down below. Okay, make sure our emergency stop is off. And so when the light is on, that means you're ready to machine if that light is lit up. Okay, it may, if that light bulb burns out though, so don't just look there. Make sure you look at your switch if you want to make sure everything's off. Okay, now what I'm going to do is I'm going to turn on the lathe, and I'm going to get close to where I want to machine. So I'm going to turn on the spindle right now, and I'm going to move the cross feed in. When I turn it clockwise, it goes in. You can see it comes out when I turn it counterclockwise. Okay, so I'm going to get close to that. Then I'm going to start feeding it towards the chuck. Now, one thing you might want to do after you've got it positioned right where you think it's going to start just taking a little bit of material off, we can zero the digital readout. So come on up here to the digital readout. We have X and Z. See, X and Z. Z is the long direction. X is the diameter. You can see right now it reads diameter. You got to make sure you're in diameter mode, that you see this little diameter up here. Okay? In order to change it, you'd hit this radius diameter button. It's going to change it between radius and diameter. You want to be in diameter because that's what you're measuring with the dial calipers. Okay, also you want to be in absolute mode. You see ABS there? Okay. ABS means absolute mode. INCR means incremental mode. So you want to be in the absolute mode when you're machining. Okay, so what you're going to do is you're going to hit the 0 button for the X. Okay, and then I'm just going to put in 0 and enter. And that zeroed that dimension. And what you're going to do right now is you're just going to say, okay, well, when I start cutting, how much am I going to cut per pass? Probably around 40 thousandths or so would be a good amount of material to take off per pass. So 40 thousandths would be 0.0400. Now there's an extra digit out here, so don't get confused by that. Okay, we want 40 thousandths, 0.040, and you can keep on zeroing it if you want, or you can add 40 each time. Now in the Z direction it really doesn't matter, but if you wanted to zero that as well, you could just hit 0 and type in 0, and then you can zero that too. We're right at the end right now. Okay, so come on back down here. You can see that we're right near the end of it. That's where we wanted to zero our part. Then any number that goes to the left will be a negative number. Okay, and then in the diameter mode, now watch what happens. If I start cranking this out, the number got larger. Okay, if I crank it in past where I was, which I can do a little bit, we're starting to get a negative number. Okay, that's just telling you right now we're 8 thousandths lower than we were before. Okay, let's try to make a cut right here and see what happens. Okay, so zoom in on here, and we're going to turn the spindle on. And then we're going to feed the long feed by hand. Okay, remember, keep your foot near the brake so that you can stop really quick. Okay, I'm going to start feeding it forward. It's taking material off. There's chips coming off. It's cutting nicely. If it makes kind of a rubbing noise or a bumping noise, that means your tool is dull, you didn't sharpen it right. Okay, so make sure I look at your tool before you go and you try to machine something, because it might not be correct. Okay, it looks pretty good. Our part is pretty round, so we're machining a full surface all the way around. I'm going to do this until I've got about 2 inches. And I can look at my digital readout and I can see where it's 2 inches. 1.25, negative 1.5, negative 1.8, 1.9, -2. Okay, I'm going to pull away from my workpiece in order to return. You want to do that. You pull your X diameter out, and then you can bring it back so that your tool doesn't drag on the surface as you're coming back. Okay, that's bad for the tool if you do that. Now I'm going to turn off the power so I can touch this and turn the chuck around. Notice that we didn't quite clean the whole surface up. We're pretty good on most of the diameter. Okay, it's smooth on most of the diameter, but there's a couple spots where we didn't quite clean up. Okay, so what I'm going to do is I'm going to come back to where I was. I was at what, -8 thousandths, and then I'm going to go another 40 thousandths. Okay, so -48 thousandths. Make sure you're not going to hit your workpiece when you're doing this. Okay, something like that. Okay, so it really doesn't matter what this diameter ends up as. Well, all we're trying to do is make a nice flat surface so that we can turn this bar around and chuck it on the nice flat surface instead of a machine surface, instead of a cast surface. Okay, so at this point I'm going to turn the power back on. I'm set up for the next cut. If you wanted, you could put a little bit more wax on it. That might help a little bit. Don't put a ton of wax on, just a little teeny bit will help. Okay, turn on the power again. Turn on the spindle, make sure everything's clear, no one's got their hands in the way. Okay, now I'm going to hand feed it again. You can see how fast I'm doing it. I'm not doing it super fast, taking material off super fast. I'm just kind of moving along, cleaning it up. Okay, our tool's starting to get dull already. I can just tell by how it sounds. So after we make this cut, we're going to go sharpen it again before we do the other side. Watch out for chips coming out at you, they're hot. Okay, there's 2 inches. I'm going to pull that away in the X, come back out in Z. Okay, I'm going to turn the power off. And let's see here. We're clean all the way around the diameter. So right now, we can flip this part around and start to machine the other end, make our screwdriver out of it. Be really careful. This is a very dangerous piece of equipment. One thing I want to point out is that if I go and I sharpen this tool, I unscrew it from here, and I sharpen the tool, and then I come back here, is your digital readout going to read the same thing as it did before? No, because we move this, right? Once we move this, you have to re-zero your tool each time. So you got to be real careful not to just always assume that your digital readout is reading correctly as to where you were before. The other thing is, if you move this upper slide here, you can see if you move here, okay, this moves independently of the cross feed. Okay, so you can see as I'm moving this, it's not changing our digital readout. Okay, but I'll tell you what, it is changing the diameter. So one of the things you might want to do before you really start getting too involved is lock this down. You see this little screw here? You can lock that screw, and that way this won't move. Okay. Remember, this again is called a compound rest and allows us to change the angle later on when we want to put chamfers on here. The final screwdriver will look something like this. Okay, so you can see the blade that you forged and threaded, and we're going to thread inside of here. We have the outside of it's turned down to 1 inch. We have a knurled surface on here. We're going to mill in these grooves in here. We're going to machine chamfer and a flat down here, so your thumb can kind of go around that, and another chamfer on the nose and on the tail of it. Okay, so there's several dimensions on here that says on your handout what dimensions are going to be measured accurately. So you got to be really careful when you machine this not to go too far past it, because you can never put material back on. You can always take more material off, so you got to really be careful. So next step would be to Make sure your chuck is, or your lathe is powers off. Unchuck your bar, and now we can chuck it back on this end, and we're going to machine our screwdriver out of this end. The reason why we machine this is that, let's say class was over before we get this completely round, okay? Then we come back next class and we try to chuck in there. If it's not completely round, this could be sticking out on an angle. If it's sticking out on an angle, okay, then we're not going to probably get our 1-inch diameter round out of there. And also, if we drill the hole in this end and we came back again next class, that hole will not be on center anymore. It'll be somewhere else. Okay, so you really need to make sure that you're clamping or chucking on a machined surface, nice round 2-inch long machined surface like this. It doesn't matter what diameter this is, as long as it's completely round. It could be even slightly smaller than 1 inch, as long as you think you can get a 1-inch section out of the other end of the bar. Okay? So next time we're going to machine this whole, the whole length, and get our screwdriver out of it. I'm going to go about 100 thousandths. I just have to re-zero that again. Nope, that's right. Let's see here. Okay. And then what I'm going to do is I'm going to pull the automatic feed lever, which is this knob down here. I'm going to pull that out when the machine is on, and it's going to feed toward the chuck. What you're going to do is you're going to watch when that Z hits to be 4.6. Then we want to push it back in. Okay? If you get an emergency, just hit the foot pedal. The foot pedal right down here. That stops everything. And also watching for interference between the chuck and anything else. .1, 2, 3, 4, 5, 6. Okay, you can see that it's really important that you time that correctly. Otherwise, another couple seconds and we're going to hit the chuck. Okay, you can turn it off. At this point, what you're going to do is you're going to back up the cross feed and bring it back down. Okay, your tool right now is probably dull already because we were cutting sand and all types of other things at the surface. You might want to actually go and touch up your tool at this point. If you hear a loud noise and you see a lot of heat being generated and you hear the machine kind of grinding, stop and sharpen your tool. That's the problem, is your tool has become dull. Okay, or maybe you didn't sharpen it correctly in the first place. So let's quick touch up our tool here. Okay, at this point I have the cross slide set up so that it's got the right diameter on it. What you're going to want to do is have one of the graduate students come over and help you with that. You're going to make a small cut, and we're going to then zero your digital readout. Okay, and it's set for 1.2 inches in the diameter. If I go down to 1 inch, I know where I am. But you do have to measure it from time to time with a micrometer. You want to make sure that you put a micrometer on here and you measure the actual diameter. Okay, so at this point, I'm going to machine it all the way down. One of the things that you got to be really careful of, though, is don't bump the cross feed right here. You see this actual dial here on the cross feed? You only want to touch the one below here. If you touch this one, it'll screw up your reading here because you're moving this independently of the actual electronic measurement device. Okay, so don't touch the cross feed on the upper one. If you do bump it, let me know, and we'll have to re-zero your tool here. Otherwise, it's other thing is if you take your tool out for grinding and you bring it back, okay, it's still not zeroed. Okay, because you moved it, you have no idea where that is now, and you'll. Don't blindly trust a digital readout just because it's a nice digital number. It doesn't always tell you what the exact dimension is. It's just telling you what it thinks it is, and you might be at fault. So I'm going to machine this down to 1 inch right now. Okay, make sure to stop about at least 1/8 of an inch away from the end. You can hand feed it to the end. Turn off your feed. And hand feed it to the end. Okay, right now we should be exactly 1 inch in diameter. I'll check it here. Pretty close. Okay, within tolerance. Okay, what we're going to do now is we need to face the end of the screwdriver. Right now it's still pretty rough, whatever you sawed the end off. What we're going to need to do is actually face the end of it. Okay, so we're going to take and take the tailstock out. And we're going to take the part out of the chuck and reclamp it with only an inch of it sticking out of the chuck. And the reason for that is if we tried to face it right now, we would push sideways on this and it would chatter, it would bounce around a lot. So what we're going to do is we're going to clean the end up by taking this part, actually putting it all the way inside of here, chucking on the machine surface the 1 inch that we just created, and now we're going to come in here and we're going to clean this up. Okay, how do you do that? You're going to need to take your tool and turn it so it's facing in towards your part. So let's see if we can do that. Sometimes you got to actually move the position that the tool's in. So we're going to rotate it like that. If it doesn't go far enough, we'll have to put the tool on this side. I think we might have a problem here. We'll see. Oh, I'll actually machine it. Okay. If it doesn't reach on your particular lathe, then you'll have to put it on the other side. Okay, now we put our tool on the opposite side so you can see it a little better. And we're going to come in here. This is a roughing tool. We're going to cut from the inside of this hole to the outside. Okay, remember, look around, make sure that nothing else is going to hit the chuck area. Okay. Turn on your power and undo your emergency stop. Only take small cuts on this, and we're going to turn it on. Should be tightened. We should be all set to go. And you're going to cut from the inside out. Move slowly. Now, one of the problems you might run into is if that hole there gets too small, when you go to knurl your part, what's going to happen is you won't have enough surface area to hold your part in there. So what you might want to do is come back in here and re-drill that to a little bit larger diameter after you face it off. You remove some of that surface area for the end of your bar to sit on. So what we can do is come back in here and re-drill that hole a little larger. If you think you have enough surface area, it'll probably be okay. I think I'm gonna come in and just touch it so I remove any burrs that are on there. Okay, we're gonna put in the chuck again, lock that in place, extend the quill out a little bit, and get it close. Lock the base down with the handle here, and then we're gonna turn it on and just come in here and touch that hole up. Okay, the next operation is to drill a number 7. So make sure you look at your drill here and read on the shank it says number 7 drill hole for a 1/4 20 tap. that we're going to put in there. It says on your sheet that we want to go at least 1.5 inches into our part, and the way we can tell that is actually on the quill here. There's actually inch markings, so we can actually figure out how far we're going into our part. You can put a little bit of wax on this drill bit, on the tip of the drill bit, and what we're going to do is take our center drill out, put that back in the right spot, and put in this number 7 drill. And tighten it down. Now, one of the things you got to know about drill bits, don't tighten them way up inside there like that. This area down here is all hardened and has sharp edge on it. This area back here is not hardened, and you can actually hold it a little bit better. Okay, there we go. So let's drill this. Okay, we're zeroed at 2 inches. You gotta clear your chips out once in a while. Make sure the drill's not pushing into the chuck. The farther in the hole, the more you gotta clear it out. See the chips in there? Okay, there we go. Okay, now we're ready to measure. We're ready to put the measurements on the screwdriver.